Hello students, on continuation of AC circuits, last class we have seen that basic fundamentals of AC circuits. In our electrical fields, resistance, inductance, capacitance, these three load equipments dominating play a vital role in our day-to-day life. When a voltage is applied across resistance, what is the behavior of current with corresponding to voltage? Similarly, the relation between voltage and current in case of inductance, capacitance, we have seen. These elements, if you are connected in series, what is the behavior and what is the characteristics of its current, phase angle, power factor? If these elements are connected individually in parallel, then what is the behaviors? Okay. So, in this class, three elements, if you are connected only resistance, pure resistance and pure inductance, pure capacitance connected in series, what is the current, what is the voltage drops, what is the phase angle, what is the power factor of the circuit, what is the power consumed by each element, we will see in this class. Let me recall what we have seen in previous class. We know that if the resistance connected across AC supply, then V is this V, this is called I, this is called R. Then what is the relation? Voltage is normal, current is also in phase. The phase angle between both are phi is equal to 0. Okay. If you draw the vector phasor diagram, this is the voltage, and this is the current. The phase angle between the two waves are phi is equal to 0. And we have seen that current is equal to simply voltage by resistance, and power is equal to, we have seen, I square R V square by R V into I. Okay. These are we have seen in previous class regarding in pure resistance. If it is connected inductance, then what will happen? If same source, if we are connected to our AC supply, this is a L, this is a I, this is a V. Now, whatever the inductive value, its a unit is a Henry. What we have seen? So, L is a inductance, Whenever supply is given to the inductance, it establishes magnetic field around the conductor. Hence, it is opposes the some ohmic value. So, whatever the L is given, it should be converted, multiplied with the omega L, then it converted into ohmic value. That is equal to 2 phi f L. So, 2 phi f is the frequency, L is the inductance in henries. Then it becomes to the ohmic unit is the ohms. Then what is the current here? I is equal to V by ohmic value. Here what is the ohmic value here? So, that is equal to, we can say this is equal to V by XL, that is the inductive reactance. So, we can say this is equal to XL. V by 2 phi f L, that will gives the current. Okay. So, now as you know that the power consumed here, during the, so what is the relations between our voltage and current? We know that the voltage is this direction and the current is nearly lagged by the maximum 90 degrees in this case. The angle is 90 degrees. If you draw the phasor diagram, this is the voltage, but our current, our current is the maximum 90 degrees displacement. That means after started here, this will start here. The phase angle is equal to 5 by 2. Okay, this is 5 by 2 is the phase angle. So, we can say that this is the current, this is the voltage. Here the current is lagged by 5 by 2, 90 degrees maximum. Okay, the pure inductance. Now, at the same time you can observe one thing, the power, what is the power consumed by our inductive load. During the positive off cycle here, whatever the power taken from the during the positive cycle and establish the magnetic field and store the magnetic field as a half Li square. Energy stored in an inductor is a half Li square. During the negative cycle, whatever the energy stored in the form of electromagnetic field, that is given to the line once again. So, during the positive cycle it will take, during the negative cycle it will gives to the line. Similarly, a positive cycle will take and gives such a way that, so net average power consumed from the line is equal to 0. Okay. So, we derived that equation also in a previous class. Okay. Now, coming to the another important element is the capacitance. Okay. So, what will happen if in this case, if the capacitor is connected across our supply, then C is the capacitor, unit is the farads, okay, it is the farads, then the current is equal to I, voltage is a V. Then what is the relation? In this case we have seen that voltage is this much, but in this case the current is leaded by maximum 90 degrees. This is I. Okay. So, that means whenever the capacitor is connected across the AC supply, it will take draw the current in the leading power factor. If you draw the diagram, so this is the voltage, it's normally the reference value, then here, so whatever this one, the current, okay. So, you can take here the current which is, so instead of here it will start at here, but it will advance 90 degrees, it will start only here only. That means this is the current, this is the voltage. So phase angle between this is the phi, that is the maximum phi by 2 in pure capacitance. Okay. So what is the current? I is equal to V by ohmic value. What is the ohmic value here? So ohmic value is equal to, so we can write it capacitors C. Here C is given, C in farads. So we have to make it XC. How we are going to make the XC? XC is equal to 1 by omega C. What is the omega C? 1 by 2 phi f C. Then it converted into ohmic value. Okay. So here what we have seen, XL is equal to omega L, XC is equal to 1 by omega C. Dear students, don't confuse. Okay. This is an inductive circuit, this is a capacitive circuit. Now this is a value XC, you are going to substitute. So here V by XC will gives the current value. Okay. So whatever the current will comes, that is leaded by angle of phi by 2. Now what is the power? Similarly in inductive circuit, here also during the positive cycle, so whatever the capacitance connected here, during the positive cycle it will take the charge the plates. So charge the plates here, and during the negative half cycle, whatever the charged, that is a half Li square we know, that is given to the once again circuit. During the positive cycle will take stored in the form of electrostatic field, and during the negative cycle it will gives to the line. Then what is the average power consumed by our capacitor? P is equal to, now what is that one? During the positive will take, and during the negative cycle it will give. Then what is the average of this value? Becomes to the 0. So we conclude that the resistance always take the power. Here the voltage, father and mother I are in phase. The phase angle is equal 0. Then current I is equal to V by R simply. Then power is equal to P is equal to V into I. So this is the power. So always consume the power during the positive cycle, negative cycle always eats. Now coming to the another, that is the inductive circuit. Okay. Then if this inductive circuit, whatever the L is given, you have to convert into XL. Once XL converted, then in this case the voltage is the same for reference, father, and mother is lagged by 90 degrees. This is the I. The phase angle between this voltage and current. That means here what is happen? Voltage phase here is this direction, and is a mother also this direction. Both are same directions. Now in this case what will happen? So father is this direction, but your mother is so bending our phase, so here up to this direction. Okay. So that means here 90 degrees, 5 by 2. Okay. She is seeing towards the ground, she is seeing this direction. Okay. So that means here what is the current? Current is equal to V by XL. Then what is the power? Power is equal to average power is equal to 0. Okay. So that means here whatever the current is lagged by 90 degrees in pure inductive circuit. Now coming to the another, this here, so capacitance. In capacitance, So what will happen? So whatever the C, you have to convert into XC. Then if voltage father is connected, in this case our mother is advanced by the 90 degrees. So we can say the current is leaded by voltage 90 degrees. Then what is the current? That I is equal to V by ohmic value, that is the XC. Okay. Then in this case what will happen? So our father is the same direction. So but it is a V, but what will mother? Mother will see upside. So he is seeing this one. So our father is seeing this direction. So your mother is seeing upward. Okay. Phase angle, what is the phase angle? Nearly 90 degrees here. Then power, so whatever the power is equal to 0 here. So dear students, these are the conclusions we have seen and clearly with the derivations of our this resistance, what is this values, inductance and capacitance. Okay. Now these are the individual we are connected in the AC circuits. These are behaviors, our mother and father behavior, in phase or lagging or leading. Okay. Now coming to the, if these two, so here the brother and sister and another sister is connected, what will happen? So let us see if this resistances. Now if here some resistance and inductance, two children connected to the his father, then he has to manage this one, resistance, then we connect the inductance. Then I want to know the what is the current, this is the voltage. Okay. So what is the phase angle here? So we know whatever the ohmic value, you have to find it. Here this is ohmic value, this is a kids, we can write the kids. Previously only one resistance, only one inductance. Now the combination of both kids, now you can say the children. Okay. The children indicated by the ohmic value, the combination of children's, we can say the impedance. Okay. So that impedance is indicated by the Z. That is the combination of 2 or 3. So Z is equal, we can write it, Z is equal to a resistance plus J of X value. So here the X value, what is the X value? X value is the reactance value. Reactance value, we haven't seen the what is the reactance also. Here, so only inductive. So here reactance value is equal to here XL only. So inductive reactance. Inductive reactance. So what is the unit of inductive reactance? It's a ohmic value. This is the unit is ohms. So what is the XL? XL is equal to, already we have seen that, omega L, that is equal to 5 f L. Okay. So that means whatever the L is given initially, that is a unit is a Henry. Okay. Now that should be converted into ohmic value, that is the omega L, that is equal to ohms are unit is ohms. So these are the required unit. Now what is happen, if we know this value, I will find the Z value. If Z value knows, then I will find the what is the current value. I is equal to V by Z here. Okay. So both, what is the here? So V is equal to by R whole square plus XL whole square under root. Then I can find the what is the current value. Okay. Now I want the phase angle. So here what is happen? If you draw the vector diagram, this is the current, resistance, this is the XL. So J is represented here. This is known as the Z. This is a phase angle. Okay, combination this. So if we know that this we can say is the impedance triangle. Already we have seen impedance triangle, similar to the power triangle. Now, so we know the resistance, we know the XL. So what is the, as per Pythagoras, Z square is equal to R whole square plus XL whole square. This we know. I want the Z. So Z is considered is equal to magnitude I required root of R whole square plus XL whole square. Okay, this is the magnitude I required Z impedance value. Suppose I want the phase angle. So what is the tan phi? Tan phi is equal to, so XL by R, sin theta by cos theta. So I require the phi angle, for example. Phi is equal to tan inverse of XL by R. So I can know the phi. If you know the phi, I can calculate the cos phi. So cos of this value, I am going to the power factor. Cos phi is equal power factor. Or I can, from this one, what is the cos phi? R by Z. Directly I will give. So here R by Z. R is the resistance, Z is the impedance. From that, so I can calculate what is the current value here. Okay. So what is the current value? What is the current value? Then what is its phase angle and what is the power factor? I can easily calculate it. Okay. So what is the relation in this case? Here what is connected? Here both resistance and inductance connected. That means if you know that value, so if you take the, this is the value. Now our voltage is the same. So reference, if we take the reference, then so our current value, so what will do to the inductance? It lagged, that is the, it will start at slowly. So this is lagged up to this one. So wherever the it's starting this one, that means here it started voltage, but our current is started here. What is the phase angle? This is the phase angle between these two vectors. Okay. So if resistance and inductance connected in both together, the maximum, the phase angle is equal phi by 2, but it is less than the phi by 2. It should be the phi by 2, less than phi 2. That means if you draw the vectors, here the voltage is this much and current is this much. The phase angle phi is equal this one. Okay. So this is the basics. Okay. Now coming to the, if resistance and inductance connected, what is happened? If this resistance and capacitance connected, in this case, what is going to, same similar process. Whatever the resistance is given, what is the capacitance is given, microfarads, this is the voltage, this is the current. Okay. So if C is given, you have to convert the XC. Okay. So XC value, what is the XC value? XC value is equal to 1 by omega C. So if you multiply this value, you are going to the in ohmic value. If you know the ohmic value, then I can calculate it, its impedance. So this is equal Z. Okay. So what is the Z value? Z is equal to R minus J of XC here. Capacitance, you have to take the minus, because here current is the leading power factor. What is the phase angle? Let us see about that one. So first, this is the our voltage. Okay. Now our current, in this case, leaded. So he started here. So instead of this one, so here whatever the started, so you are going to start here only. That means here only. So before, this is advanced, this is a current, this is a voltage. That means the voltage is similar V, but our current is leaded by some angle, not 90 angle. So pure is a 90 angle. Due to the resistance present, the current is only 5 angle. Okay. So this is the phi. What is this phi value? I want to know. So here Z is equal this value. What is the magnitude Z? So similarly, so we are going to draw that vector diagram. That means this is equal to R and this is equal to XC. Okay. So this is the angle is equal Z. This is equal phi. Okay. Now I want to know the what is the Z value. So Z square is equal to R whole square, okay, plus XC whole square as per Pythagoras. This is 90 degrees. So Z is equal to, I can write it under root of R whole square plus XC whole square. Z. If you know the Z, I can find the what is the current. So current is equal to V by Z. Okay, what is the V is given? That one is substitute. V is equal to whatever the V. So we can AC, that is equal to V max sine omega t. That is one. Okay, so whatever the V is given and Z we calculated from here, and we are going to get the in amps current. Then phase angle I required. What is the phase angle here? So tan phi. Tan phi is equal to, what is the opposite? XC by R. So we are going to get it. So from this one, phi is equal to tan inverse of XC by R. We are going to get it. If you know the phi, I can calculate the cos phi. So I can note the power factor. Or I can write from the my impedance triangle, I can find it. What is this one? Cos R by Z. Similarly, I can get the R by Z as the power factor. Okay. So these are the procedure, similar procedure when resistance, capacitance connected, when resistance and inductance connected. Similarly, so you are going to find that if both only resistors connected, that means if the inductance and capacitance connected, what is the current and what is the power factor, what are the relations, similar that one. Okay. So this is also same thing. So dear students, if same procedure, so what we have seen? So we have seen separately here the our resistance and inductance connected in series. We have drawn the vectors and phasor diagrams. Based on this one, we calculated Newton the impedance. Impedance is called R plus J of X, and based on this one, we calculate the current and phase angle and power factor. At the same time, if required, I can calculate the power also. Power is equal to V into I can calculate. If in second case, I connected resistance and capacitance. Here the capacitance connected XC, this is a capacitive reactance. What is the capacitive reactance? This is the formula. If you know the capacitive reactance, I can easily calculate the Z. If you know the Z, I can calculate the current. Okay. So I can calculate the Z and I can calculate the current here. If you know the current, I can know the what is the phase angle, what is the power factor. Okay. So this same procedure. If connected both, then similarly you connected what is the Z here and what is the current here. So everything is the same. Okay. So dear student, draw the vector diagrams, everything is similar. Okay. So now let us draw one, what is that one? Let us draw three connected in series. What will happen? Okay, let us do similar procedure. Now I can draw the okay. Now sorry, don't worry. You can take it this one. Here I connect the resistance. Here I connected the inductance. Here I connected the capacitance. These are connected to the our source, AC source. Resistance, inductance, capacitance. Okay, so these are connected in series. Applied voltage is V, the current which is passing the I. Then what is the, you can, if it is possible, I can find the what is the VR, voltage drop, what is the VL, what is the VC, I can easily find. Like this one. Okay, now I want to know that what is the similar processor. I want to know that what is the current. Okay, what is the power factor I required, similar case. Now you can see when it is connected, the first step 1 you have to do, so these are the connector. Okay, so RLC. So if you given this one, you convert it into this. L is a inductance. What is the unit? Henry. Okay, Henry. What is this one? Capacitance. What is the unit? Farads. So, but what will happen? It has to convert into XL, it has to convert the XC. So, because it is a Henry farads, so it should be converted to the ohmic value. Okay. So, then first you convert these 3 childrens into Z, equivalent Z. If you know the Z, I can easily calculate what is the mother. I is equal to father by Z. Okay. So, what to do? Step 1. Step 1. So, R is equal to, it is a in ohmic value 1 ohms. L is equal to, in given the Henry. So, you should convert into ohms. Convert into ohms. How we are going to convert? So, whatever the, that is equal to XL, convert. XL is equal to omega L, that is equal to 2πf L. Okay. So, then it converted into ohms, is ready for action. Next, similarly, whatever the C is given, what is the unit? Farads. Now, it is unable to participate in the game. Now, it has to practice it, it has to train it. How we are going to train it? That is equal to XC. What is the XC? Capacitive reactance. Then 1 by omega C. Then it is a training, under training. Now, it becomes a 2πf C. So, now it is a trained, it is a ready to participate in the game. Second. Okay, these are the first step. Whatever the values is given, that should be converted into ohmic values. Okay. Now, step 2. Step 2. So, now find the, combine the all childrens, that is equal to Z. Z is equal to R plus J of reactance. Okay. Here, what is the X? X is equal to reactance. Reactance. Now, this reactance, that is equal to, we can write it, X is equal to XL or XC, whatever the big value you subtract it. So, we are going to get it. So, already we know that XL, we know that what is the XL here? So, 2πf L. So, what is the value? Now, what is the XC value? That is equal 1 by 2 phi f L. If you know this value, if you know value, you are going to get this x value. If you know the x value, simply you know the resistance will give. So if you substitute here, you are going to get the Z value. Okay. So Z value is equal to, we are going to get it, R plus J of x value. Then I want the magnitude. So based on this one, you draw the one vector diagram. This is equal R. For example, here, so XL, you can take this XL for X value, reactance value. For example, XL value is equal to greater than the XC. So this value is equal, for example, 36 ohms. This value is equal to 28 ohms. Then the difference we can write it. Or sometimes there is a possible to XC minus XL also possible. When, so for example, this is 40, this is equal to 20. So that may be possible. So in this case is known as the capacitive circuit. This case is known as the inductive circuit. Okay. So we can draw the vector diagram also if three are connected. Here this resistance is connected here. Now before this one, I want to draw the vector diagram also. Okay, let us do. So here this is the resistance. Now what are the XL value calculated? I am going to this XL value, this direction. So this is a J. So I taken, this is the current, the reference, and from the reference, this is the voltage, that is XL. I into XL is the inductive voltage. That is lagged by the current is the 90 degrees. Now XC, so XC is the leaded, that is equal, this is the XC. I into XC is equal voltage across the capacitor. Now what is happen? So current is leaded 90 degrees here. So this is a XC, this is a XL. Okay, now let us first case, if you are saying the XL is greater than the XC. How much? For example, this is equal to, so whatever the value, so 36 and this value is equal 30. What is the difference? 6. So here it is a 30 and from that you are going to calculate. This is a 36 up to this one equal. Now what are the value? This is equal to up to this one. So whatever the value taken the here and this value. So remaining portion up to this is a 6. So I write it, this is this value. So this is equal x. Okay. So this value equal to this value. So this is a 30. Now this is a 30 in our example. Now remaining this is a 6. So here what will happen? So this is called Z, this is called x, this is called angle. So from this impedance triangle, I can calculate its angle also. So how we are going to calculate angle here? So angle can calculate it. So that is equal to tan phi I required opposite x Z, that is the R. I can easily calculate it. The phi is equal to tan inverse of x by R. I can calculate. Or if you require the power factor PF, R is equal cos phi. So cos phi is equal R by Z. So easily calculated. In this case, what are the power factor will comes? Lag, because here the inductance value is greater than the capacitor value. Okay. So these are the steps, dear students. If you know the Z, so up to what we are, so we have calculated up to Z. Okay. So I calculated what is the Z value. If you know the Z value, if you know the voltage, I can easily calculate what is the current. What is the current here? So I is equal to V by Z. What is the V? V is given directly here, and Z, what is the Z? Z is equal to R plus J of x. So this value known, this value known, this value known, I can easily calculate the current value. If you know the current value, cos phi also we can calculate it from the vector diagram. It's over. Then suppose I require the power. So power is equal in the circuit. So only power consumed by the only resistors, not inductors, not capacitor. That is equal. I can write it the, if you know the current, I can I square R. I know the I from this one. I know the resistance is given. I can calculate the what is the power in watts. So this is a simple steps, dear students. So what are the steps? Step 1, whatever you are going to convert the ohmic value. Step 2, find the Z. Step 3, find the current. This step, for example. Step 3, find the current. Next, step 4, find the phase angle and power factor. Step 5, find the power, whatever you required. So this is the procedure, dear students. Okay. So similarly, you do the problems also. Whatever the problems is given, resistance, inductance, capacitance, you can easily calculate it in a similar way. Okay. So let us do one problem. You may get the clear about this series circuit. Okay. So let us do one that thing. Now, so what is the given problem? So cases, if you one problem is take it. Okay, here is one problem is given. What is that problem? A resistance of 12 ohms, inductance 0.15 henries and capacitance 100 microfarads are connected in series across a 100 volts 58 supply. Calculate its impedance, power factor, current and power is asking. Okay. So what he is asking, and the problem is this, such a way that okay, I can take the problem. What is the problem is given? Here is a one resistance is given, and inductance is given, and capacitance is given. Okay, is connected to the voltage. So a resistance of 12 ohms, 12 ohms is given, and inductance L is equal 0.15 henries. So you have to convert the ohmic value. And capacitance C is equal 100 microfarads. Microfarads is given 100. Okay, 100 microfarads is given. Are connected in series across a 100 volts. Voltage is given at 50 Hz frequency is given. Find, what is asking? Find what is the Z, what is the power factor, what is the current, what is the power. So he is asking these 4 terms. Okay, how you are going to calculate? Simple. Okay, so whatever the value is given here is asking the current. Okay, what is the power factor? Everything you are going to calculate. So first of all, dear students, what to do? Steps. So here the steps are, first whatever this value. Okay, so you calculate the Z, that is enough. Before going to the Z, you convert, it should be converted the ohmic value, convert into ohmic value. If you know the ohmic value, Z easily calculated. If you know the Z value, so V by Z we are going to do the current. So if you know the Z value, if you are going to draw the impedance triangle, you are going to find the what is the phase angle and power factor. Then if you know the current, if you know the resistance, you are going to the power is equal I square R. Okay. So here what you are required? So you are going to require, so Z is equal R plus J of X. So for this purpose, X you are going to calculate. What is the X? X is equal to XL minus XC, whatever the value. What is the XL? That is equal omega L. L is given, omega 2π, frequency also given. And what is the XC? 1 by omega C is given. So what is the omega? So that is equal to 2π f L. So L is given, frequency is given, 2π, multiply it. Then what is the omega C? That is the 2π f C. So everything is given. So based on this one, we are going to calculate this omega C Based on this one, you are going to calculate this one. And so here, whatever the value got it, so here you can subtract whether your XL is greater than XC or vice versa. So whatever the value, you are going to get the X value. If you know the X value, substitute in R. Already R is given, resistance how much is given? 12 ohms. If you know this one, so we are going to get the Z value. Z value we know. So if Z value known, then simply draw the impedance triangle. This is the R, this is the X, this is the Z. This is the phase angle. From this one, you are going to this one. If you are going to the cos phi, everything you are going to get it. Okay. So from this one, you are going to get this one. And I want the current. So if you know the current, I is equal to V by Z. So V is given, Z you are calculated from this one, impedance triangle. Then we are going to current. Then if you know that one, I am going to calculate, if you know the current, so P is equal to I square R. I calculated, R is given, then we are going to get the power. So these are the basic idea, dear students. Okay, once again I am going to explain it, you can see it. Here resistance is given, inductance is given, but in henries, and capacitance is given in farads. Now you are going to microfarads, so you are going to convert. Resistance is no problem, but inductance you are going to henry to ohmic value, you are going to convert it. First step, a capacitance 100 microfarads is converted into ohmic value. If this all are ohmic value, simply you calculate this impedance value. After knowing the impedance value, simply draw the impedance triangle. So we can easily calculate what is the phase angle, what is the power factor. That is enough. If you know that Z, if you know the voltage, so basic step 3, you know the I is equal to V by Z. This known, you are going to calculate what is the current. It's enough. If you know the current, if you know the resistance, you are going to get the power. What is the power is? So these are simple steps, dear students. Okay, let us do. Okay, here what you are going to do? So R is given, R is equal 12 ohms. Is a very good fellow. And here L is given, L is equal to how much is given? 0.15 henries is given. Okay, so I am going to connect it omega, that is XL I want this, that is equal omega L, that is equal to 5 FL. So what is the 2 phi is a constant, F is 50 Hz is given, L is equal to 0.12 is given, sorry 15 is given. Then multiplying this one, I am going to get it, that value is 47.12 ohms. Okay, the XL value I got it. Now next C value, C 100 microfarads. Now I want the connect the XC. XC is equal to 1 by omega C, that is equal to 1 by 2 phi FC. Okay, so here I am going to simple substitution 2 phi FC. Okay, so that is equal 1 by 2 phi is a constant, F is given 50 Hz, and C is given 100 microfarad 10 to the power of -6 is given. Okay, then I am going to get by simple calculator, with help of the calculator, I am going to get this value is the 31.83 ohms. So this is called XC. Now dear students, you can see it. So what is the XL? XL value I am going to get it 47.12 ohms. XC value I am going to get 31.83. Now what is happening here? XL is inductive reactance greater than the capacitive reactance. So our circuit is always the current is lagging. From this one we can easily calculate it. Okay, if you know this XL, XC, then we find the what is the reactance, net reactance. Okay, what is the net reactance here? So XL minus XC, that is equal 47.12 minus 31.83. Okay, so then you are going to get it. So the difference of this value is equal 15.29 ohms. So X we know. Okay, so R already given. What is the R value is given? 12 ohms is given. So from this one, better to draw the vector diagram. So this is the R12 and this is the inductive. This is equal to 15 point. This is the, that's the X and this is the Z. So this is the phase angle. Okay, now I want to know this value known, this value known. I want to find this one. Okay, so what is the Z? Z is equal to, so that is equal to R plus J of X. Now substitute this value. This is equal to 12 ohms plus J of 15.29. Okay, this is the Z. From this one you calculate the, just to convert to the polar form. So we are going to get what is the Z value. So Z value is equal to, or otherwise we can the simple method, 12 whole square plus 15.29 whole square under root. So but you have the calculator, simply convert the polar form better. So you are going to get it 19.43 ohms. Z we know. Okay, now if you know the Z, so what is the current? You find the what is the, so at the same time you find that power factor also. From this power factor, this diagram, so we are going to calculate power factor, the cos phi. Cos phi is equal to R by Z. What is the R here? R is equal to, directly is given 12 ohms. What is the Z? We calculated now in this case 19.43. 19.43. So then you are going to get it directly, that is equal to 0.6176. Leading current lagging, so inductive always lagging. So power factor also calculated here. Okay, power factor also calculated. What is the cos phi? Cos phi R power factor PF is equal to 0.6176. Okay, lagging. So this is the required thing we calculated, and at the same time this is the required thing I calculated. If you know the Z, if you know the voltage, so V is given, how much is given? 100 volts is given. Then I want the current, I is equal to V by Z. So what is the V? 100. What is the Z? 19.43. So what is the value I am going to get it? So that is called nearly the 5.145 amps. This is the current, 5 amperes. So 5.145 amps I am going to get the current inside the circuit. Okay, so this is the required. So I is equal to, I got it, 5.145 amps. This is the required thing, I know it. If you don't think, so what is the here? The power is required. Power is equal to I square R. So I known, substitute this value 5.145 whole square into resistance. What is the resistance? Is 12 ohms. Then I am going to get it, simple calculations. So I am going to 318 watts. So this power, simple. Okay, it's over dear students. Okay, so let us see once again here what we have seen. This circuit is given such that a resistance of 12 ohms, inductance 0.15 henries and capacitance of 100 microfarads connected in series across the 100 volts 50 hertz supply, and find the impedance, power factor, current and power. So what we have seen, first we converted the what of the henries and faradays into the ohmic values, first step. Then we calculated the impedance. Then we calculated the current. Then we calculated the power factor. Then we calculated the power. Okay, how we are connected the inductors? So whatever the values is given here. Okay, so whatever the value is converted, the farads to that one we converted simply just multiplying the omega value. So L is given that is converted to the XL. So that value is going to this one, and C is given, we convert the XC. So we converted that, we are going to get it, XC is calculated here. Once XL, XC, R is known, so we calculate the resultant X value. If you know the X value, if you know the R value, I calculated the Z, that is enough. If you know the Z value, so I can draw the simply my impedance triangle. From that I can easily calculate what is the phase angle, what is the power factor, similar this way. Once after known the Z value, I can calculate the voltage is given. Then I by Z, I am going to get the current. If you know the current, then I can calculate the what is the power. Power is equal I square R. Then I am going to get the power factor. Sir, power. So these are the simple way, dear students. Please do the remaining all problems. Okay. So this if you practice, you may get the command on this one. Okay. Thank you, dear students, for listening to my class.